California three-way alternate scheme, while innovative, has a fairly restricted application in the real world. It's primarily found on certain segments of California State Route 1 and California State Route 390 freeways. The reasons for its limited adoption stem from a few factors. Firstly, the specific conditions required for its effective implementation are not universally present. The scheme is designed to manage traffic flow efficiently in areas with unique geographical or traffic patterns. Secondly, the complexity of implementing and maintaining such a system compared to more traditional traffic management methods can be a deterrent. The California three-way alternate scheme requires careful planning and coordination. This includes the installation of specialized equipment, ongoing monitoring, and adaptive control strategies. The purpose of the scheme is to provide a way to route traffic using sensors to open or close routes that become available. This helps to avoid congestion and also to improve overall traffic flow in the locations that it is installed. Thirdly, the cost-benefit analysis might not always favor the California three-way alternate scheme. In situations where simpler solutions can achieve similar results, the additional investment in this more sophisticated scheme might not be justifiable. The effectiveness of the scheme can vary depending on the specific context. Traffic volume, road geometry, and the presence of other traffic control measures will play a role. It's not a one-size-fits-all solution. Fourthly, public awareness and acceptance can influence the adoption rate of new traffic management schemes. If drivers are unfamiliar with how the system works or distrust its effectiveness, they might be less likely to cooperate, reducing its overall impact. Consider a typical highway scenario where traffic is flowing smoothly in both directions. Now imagine a situation where an incident occurs, such as an accident or road work, that blocks one of the lanes. In this case, the California three-way alternate scheme could be employed to redirect traffic onto the opposing lane, effectively creating a temporary three-lane configuration. This would allow traffic to continue flowing in both directions, albeit at a reduced speed, while the incident is being resolved. To accomplish this, the scheme relies on a combination of sensors, traffic signals, and dynamic message signs. Sensors are used to detect the presence of traffic and monitor its flow. Traffic signals are used to control the movement of vehicles into and out of the temporary three-lane section. Dynamic message signs are used to inform drivers about the change in traffic patterns and provide instructions on how to proceed. One of the key challenges in implementing the California three-way alternate scheme is ensuring the safety of drivers. To mitigate the risk of collisions, several safety measures are typically put in place. These include reduced speed limits, increased enforcement, and the use of barriers to separate opposing lanes of traffic. Another challenge is the need to coordinate the scheme with other traffic management systems. For example, the scheme might need to be integrated with ramp metering systems or traffic signal control systems to ensure that traffic flows smoothly throughout the network. The California three-way alternate scheme is an example of how technology can be used to improve traffic flow and reduce congestion. While it is not a perfect solution, it can be an effective tool in certain situations. The selection of a traffic management scheme depends on a variety of factors. These include the specific conditions of the roadway, the volume of traffic, and the availability of resources. It is important to carefully consider all of these factors before making a decision. Traffic engineers and transportation planners employ a variety of techniques to optimize traffic flow and enhance safety on roadways. These techniques range from simple measures such as adjusting traffic signal timing to more complex strategies like implementing managed lanes or utilizing intelligent transportation systems. The goal is to create a transportation network that is efficient, reliable, and safe for all users. Firstly, traffic signal timing optimization involves adjusting the duration of green, yellow, and red lights at intersections to minimize delays and improve traffic progression. This can be done manually by traffic engineers or automatically using computer-based systems that analyze real-time traffic data. Secondly, ramp metering is a technique that regulates the flow of vehicles entering a freeway by using traffic signals on the on-ramps. This helps to prevent congestion from forming on the freeway main line. Thirdly, managed lanes are freeway lanes that are reserved for specific types of vehicles, such as high-occupancy vehicles or buses. This can help to improve traffic flow and encourage the use of public transportation. Fourthly, intelligent transportation systems encompass a wide range of technologies that are used to monitor and manage traffic flow. These systems can include sensors, cameras, and communication networks that provide real-time information to traffic managers and drivers. Fifthly, incident management is a critical aspect of traffic management. When an accident or other incident occurs on a roadway, it is important to respond quickly and efficiently to clear the incident and restore traffic flow. This can involve coordinating the efforts of police, fire, and emergency medical services. Sixthly, work zone traffic management is another important area of focus. When construction or maintenance work is being performed on a roadway, it is important to implement measures to protect workers and maintain traffic flow. This can include using temporary traffic control devices, such as cones and barricades, and providing detour routes for drivers. Seventhly, public transportation plays a vital role in reducing traffic congestion. By providing an alternative to driving, public transportation can help to reduce the number of vehicles on the road. Eighthly, transportation demand management strategies aim to reduce the demand for driving by encouraging people to use other modes of transportation, such as walking, biking, or taking public transportation. Ninthly, travel demand management strategies also include encouraging people to travel during off-peak hours or to work from home. Tenthly, parking management can also be used to reduce traffic congestion. While limiting the availability of parking or charging higher parking fees, cities can encourage people to use other modes of transportation. The California Three-Way Alternate Scheme is a specific example of a traffic management technique that is used to address a particular problem. However, it is important to remember that there are many other tools and strategies available to traffic engineers and transportation planners. The key is to select the right tool for the job and to implement it effectively. When evaluating the effectiveness of a traffic management scheme, it is important to consider a variety of factors. These factors can include the impact on traffic flow, safety, and the environment. It is also important to consider the cost of implementing and maintaining the scheme. The ultimate goal of traffic management is to create a transportation network that is efficient, reliable, and safe for all users. This requires a comprehensive approach that considers all aspects of the transportation system, from planning and design to operation and maintenance. The California Three-Way Alternate Scheme is just one piece of the puzzle.